We will try to explain how to use line buffer to do our convolution. So when you apply it to image processing, we have an image like this. We take an image like this from the camera. We have a lot of pixels like this, line by line. Now we want to do the kernel, which is 3 by 3, to do the convolution. So this is how the convolution is done, like this. So, or something like this. This is our kernel. We have 9 elements like this. So we need to multiply this element with this pixel plus this element with this pixel plus this third element with this third pixel. Same thing with this fourth pixel line in our image, also with this with this. And we need also to get to the next line of our image, multiply it by this, and this by this, by this. We do summation of these sums, these products. We divide it by 9, and we get one value. Value represents this pixel, so we replace it in this pixel, and we move our kernel from these 3. Next we will do this 3, following 3 like this. So it used to be like this. Now we need to move it like this. First case, when it was this, the result of this multiplication will become here. We replace this pixel. When we move it with 1 pixel like this, the result will be here. The result will be here. Then we need to move another time, and the result will be here. So basically, what we are doing in our image, so this is our image. We are calculating this, we calculate this, we move, we calculate this. Then we go to the following line, of course, using the same idea. Sorry. Our kernel will be here. We calculate this. We move to the next line. The kernel also will have the values one by one. So the result, of course, will be another image, but this time the pixels will not be original pixels, but pixels that we have calculated and done the convolution of all neighboring pixels. For example, this pixel will be the result of multiplexing with this. Will be the result of this. Multiply this one of the image with this member of the pixel plus this one multiplied by this. Then this pixel multiplied by this value. Again for this, and the last line of the kernel with these pixels, and the result will be put here. In this way, we'll replace pixel with the 9 neighboring pixels, sum by 9. So this is the idea of the convolution. Now we'll see how to use the line buffer. It is the main idea. So we'll have our image. Same way of thinking. We have pixels. But how to do it in streaming? We are not having something like that. We have by pixels. We have something like this. We need to put it in this way to display it, but in reality, from the camera, we have something like this. We need to do. The data is coming here. For for example, this is coming from here, this coming from here, this coming from here, coming from here. Then we move to the next line, next value, until the last pixel of this frame, because in the case of video this is frames. So what do we need to do? We need to put this value in a line buffer with the same size of our image. So this one, first one will be put here, this one, second one, so this is just a representation, and this is actual camera. So this just to explain, the reality is this. So here the second one, following one, the following one, the following one. But what happens when we go to the following line? We need, of course, another line buffer. So we put this one here, this one here, until we finish same way. We move to the second one, data keep coming. We need another third line buffer. Same thing. Question: how many buffers do we need? It depends on our application. In our case, we need to calculate this. We need one line buffer here, one line buffer here, one line buffer here, and we multiply all with our kernel. So our line buffer, we put one, and we extract in this time this and this and this. Every time we need to extract 3, because these 3 pixels. From here we extract 3 pixels. From here we extract 3 pixels. So we have 9. Then we multiply by our kernel to get one value. Same thing if we move our kernel here, how it is represented here. Same thing we do. We keep filling the line buffer. We remove these 3 and put the following 3. So this one comes here, this one comes here, this one comes here. It is if like we have moved one pixel, and we do the same thing for the other 3. We move one X. Also we move one to the right, so this one will be out, and we move this at the same time while the data are coming. So in this way we do the convolution. So we need 3 line buffers, same kernel, to calculate each time new pixel that we need to store to get our output image, which is the image after convolution. So this is the principle. We'll try to implement it. Of course, we need first a control, which will do this copying to the line buffer. First one, second, third. Of course, we will show that we need a fourth line buffer, because while we are doing the calculation or using these 3 line buffers, the data don't stop, they keep coming, so we need to store them somewhere. When we finish this one, at the same time the line buffer will be using all the pixels. We will finish the 3 line, then we move to the following line. When we finish this new 3, at the same time we have to be copying in this first one. So at the same time we are using 4 line buffer each time. We will explain more in the implementation and you will understand more. So see you next time.